Sorry, I'm starting a little bit later than I put on the schedule, even though it is an ad hoc stream last minute anyway. Um, but I was in the middle of having some lunch. It took a little bit longer to prepare and eat, but yeah. Um, all right. So, leaving, continuing where we left off yesterday. I do have some errors here that I need to have a look at. Why they suddenly pop up? Behind the scenes, I rebased a few things, so I probably screwed something up. Let's hope it's not something bad, and just have a quick look at what it is complaining about. So, collision hand is one of the things. Oh, I just left that in yesterday, didn't I? So let's take that out. Is it happy now? All right, let's see if that was all that we needed to do. Let's reload our current project. See if our errors are gone. That looks healthy. Okay, don't leave test stuff in your code when you're working. Okay, so since yesterday, been doing a bunch of reading, a lot of talking on Discord, and learned a few things. So we shall see what we can come up with today and see if we can actually improve this stuff and make it work. So there are a couple of things that we need to change here and start figuring out how to make work. And it's really interesting because, well, let's just start and actually let's just write them down. So there's three things that we need to do. The first is that we need to turn off inertia. And I might actually do that last because I want to see how much difference that actually makes. Because there's also an alternative is actually taking the inertia into account. So what do we mean by turning off the inertia? So when we look at any object, I don't know, pick something random, pick a controller, boom, all right? Controller has a certain shape, certain weight to it. And that means actually that the shape is going to affect how much force you need to apply in a certain direction to get the same acceleration in velocity, rotational velocity. So it actually takes more strength, hold on, or more force, I should say, to rotate the controller on its y-axis because it's, it's a wide controller, than, to roll it like this because there's less momentum needed to roll it that way. So if we are trying to rotate a controller at a certain speed, that comes into play. Now, the other thing that comes into play is your center of gravity. We are rotating around the center of gravity of our controller, which might not be what we want because we want to rotate around, the origin point of the controller. So the same thing goes there, is that if the origin is not lined up with the center of gravity, the physics engine has calculated what the center of gravity is based on the shape of your collision shape, the size of your collision shape, and it might not get the rotation that we are expecting. So those are things that we can either query from the controller or from the hand, because of course, in this case, it's not the controller, it's actually our hand. And when we actually look at our hand, excuse me, can I see it here? Yeah, so if I look at one of our hands, I actually don't, do I have the scene that I'm loading here? No, I'm creating everything in code here. So somewhere in here, sorry, my nose is running a little bit. Excuse me for that. Where do I actually create it? It's been a while since I last looked at this. No, there should be an update. Update hand message here. So we add the hand skeleton in, blah, blah, blah. Where am I creating my collision shape? I'm pretty sure I create, no, that's right. I actually do much more here. I create collision shapes for every finger. So we actually get a very complex set of collision shapes for our rigid body, and it's a collection of those that will eventually lead to our inertia data. So when we look at the hands, pretend for a minute that the whole hand is a collision shape. So we're actually creating collisions for every finger and the main body of the hand, etc., etc. So basically, our collision shape is like that. So we can first of all already see that just like with the controller, the length is longer than the width, and the height obviously is somewhere in the middle. So every axis will require a different force to create the same acceleration. The second thing that we can see is that our center point is on the palm, which is what we want. But our center of gravity is probably somewhere inside of the hand. So there's a momentum difference between those two. And again, the easiest way to probably deal with that is just to turn it off, because as I think it was Avat who mentioned this on Discord, in the end, it doesn't matter because your hand is attached to your body. So an accurate simulation of inertia on the hands, especially with the hands being relatively light, doesn't actually do anything for us. So that is something that we can play around with and figure out. Now, one thing that I don't know, and that will be a reason to actually keep inertia in, and that's also why I want to do this at last, is that when we pick something up and we create a joint between our hand and the thing that we pick up, we have two things that happen. One is center of gravity changes to wherever the thing that we picked up is, and our inertia changes because the attached objects affects the inertia. So again, the big question at that point is, just like with movement, I don't know if you guys remember this from a stream that I did like months ago when I started on this, and where I got the movement right. It's one of the things that we figured out is I'm applying forces to the hand to move the hand based on the properties of the hand. And even when I picked something up, the same forces moved the hand the same thing. So it was like it moved the hand, and then it isn't really taking into account the things attached to the hand. They just move with it. And that seemed kind of strange and kind of counterintuitive. And it might be so that when you set inertia to 0, we get the same effect that if we rotate our hand, whatever we're holding rotates with it. And it's just the fact that we collide with things that start to change that. So we're going to have to figure out how much it does. And in the same thing, all right, the whole thing is how's gravity going to be impacting that? How's other factors going to be impacting that? It's going to be kind of interesting to see what we're coming up with there. So that's the first thing that we need to change. And of course, I scrolled away, so now I need to find where we were editing this, I think, physics process. Here we go. Yep. So that's the first thing that we want to do is, I'm going to actually put a question mark at it. Turn off inertia or apply inertia. We'll do this last. And again, when we turn it off, our hit controller settings will change, but we'll see about that. So the second thing, second thing we need to look at is something that I actually talked about in my stream yesterday that I've already figured out I was doing wrong, is we are getting our rotation, or I should say we're getting our target rotation. So how much do we want to rotate the hand from its current position to where it goes? And we're getting that as a matrix, as a 3x3 matrix, which is what our basis is. And we're then getting our Euler angles. And three angles, three values seem to be what we want to do here. But it turns out that when we are looking at physics and rotational energy, those are not Euler angles. Smells like a duck, quacks like a duck, whatever the expression is. In this case, not a duck. So rotation data is not in Euler angles. Hey, Mr. Squareback, how you going? Nice of you to join. So what is it? Well, actually, when we look at our torque, and the same actually with our rigid body. Do we have a rigid body somewhere over here? Yeah, this is a rigid body. So when you look at here, we have an angular velocity. Again, it looks like, hey, I've got three things. Those must be the three angles of rotation. And especially because it says degrees per second, kind of, is what we think it is. That's actually not what it is, unless we do some weird calculations in the background in Godot. No. This is actually something else. And from what I understand, therefore, the applied torque is also different. So what is it actually? Well, it's close to what quaternions are. What we are specifying, or what we have as basically the information in the background, and you can actually, when we go to basis, for instance, we actually have this. We have a vector. Whoops, I didn't mean to do that. We have a axis vector, which is the vector around which we're rotating. So let's say, again, I've got my controller here, and I've got a vector, pointing that way, like that. I am rotating. I can't really do this with one hand. I'm rotating around that vector. So that's that property. Now, the second thing is we have an angle. How many degrees are we rotating by? That's basically our input. But that's 4 values, not 3. Go away, pop up. What gives? Well, we're actually encoding this. So what we're actually having, so this is actually axis plus angle. So the nice thing is, when you have an axis around which you rotate, that is usually represented as a unit vector. So a vector of length 1. So if we have a vector that's not length 1, we can just normalize it, and we get the vector of length 1. So we can play around with that, and we can say, hey, I've got a vector, and I've got a angle. Why don't I multiply the vector by the angle? And now I have the angle encoded in the length of my vector. And that's what's happening here. So we need to change that code, that instead of getting our Euler, we're actually going to get our axis and angle, and then we have to encode it that way. And that is what we are going to work with. Now, a little side note there. It might need to be that we get our axis and angle, and we're doing a axis, what you call it? What's the word I'm looking for? So we're going to go and have our axes solely move from where we are to where we want to be, and we're going to have our angle. So we're going to use 2 PID controllers, or we just multiply those together and we have the PID controller working on, the adjusted axes. All the examples that I've seen so far do the latter thing, because having the angle calculate or already applied to the axes, all the calculations kind of go the same. But I'm not entirely sure. It feels like that could cause some issues. So there's a good chance that we will change our PID controller to actually be axis angle for this. And then, add them together later on once we've got everything done. All right. So that's problem number 2. Now problem number 3. If I go and type that right. So this is in the Angular PID controller itself. Let's say that I'm now sending the correct values here. So because we're doing our rotations on the local, in local space, we're always going from 0 to those angles. And as we rotate, as our controller rotates, every time we go from 0 to whatever we need to rotate to. So in our calculation inside of the PID controller, where we're trying to figure out what the velocity of that rotation is so that we can do our derivative, we're actually not calculating that velocity correctly. We actually need the velocity that we are reporting here. So we need to change our PID controller, and instead of the PID controller calculating the velocity, we're actually going to give it that velocity. And then we're going to apply our derivative to that velocity. That also means that we really need, no, actually it doesn't. Does it? Not sure. That's something I need to double check. I think we might need to therefore rotate this velocity so that it is in also in local space. Now, again, because it's an angle that we or a vector that we are rotating around, and the vector is just scaled by the amount, we can rotate that vector just fine. So we can, if we get that vector in global space, we can take that fine into local space. That'll work. So, and again, I still need to figure out. I'm still unclear about that, whether applied torque is actually being applied in local space or in global space. I wish that was clearer in the documentation. I still think, based on what we're doing over here. By the way, we got our inertia calculation as well, so we can do something with that. But yeah, based on the original code that I did here, I think applied torque is always going to be, and by the way, I did the same mistakes here as well. Interesting to find out if I calculate my angular movement here properly, whether the torque value here would be correct. That is worth checking actually at some point, but yeah. So point 3 is use correct velocity. All right. So yeah, I am going to assume for the moment that that applied torque is in local space. But we'll see. It'll be interesting to figure that out. Okie dokie. So let's change. There's actually a fourth one that I forgot. We can't do integral. We'll be removing these comments eventually. And let's be consistent. So our PID controller applies 3 individual things. Let's actually go into our PID controller so that I can have my wording correct. A proportional gain. I don't know if I actually went through this code yesterday and explained it, but might as well have a little bit of a talk about what a PID controller actually does. I'll just do it purely on the angle, that's fine. So the first thing that we do is we apply a proportional gain. And we multiply that by the error. So the error in this case is the difference from our current value to our target value. So how much do we need to change to get there? So let's, for argument's sake, that we're not dealing, well, no, let's for argument's sake that we're purely dealing with an angle. And we want to rotate something from 3 degrees to 10 degrees, for argument's sake. So we need to move it 7. And instead of doing that immediately 7 degrees, boom, you're there. We want it to nicely, smoothly move to there. And in this case, because we know we're purely working with angles and we're purely working with rotations, the output of our our output of our PID is going to be the number of degrees that we rotate our thingy with, right? So unlike what we're trying to do with our angular momentum, where we're not just looking at how much rotation we are doing, we're also looking at, a force that we are applying. So we're our output isn't the number of degrees. Our output is much larger. It's, you know, whatever force in those around that angle that we're going to be applying. But if we simplify it and we purely look at this example, we want to go from 3 degrees to 7 degrees, then our error will be the difference, or sorry, for 3 degrees to 10 degrees, then our error is going to be 7 degrees. So if I have a proportional gain of 1, which is our default, we're simply doing 1 times 7. Let's say that the rest is all turned off. We're purely doing our proportional gain. Then our output will be 7. So our PID controller will, in this case, apply the exact rotation that is required to get to the target, which is not what we want, because that means that we get shocking movement. We don't have, you know, a nice progression to that value. So proportional gain, in most cases, you will want to have that to be a factor of 1. So say that it's 0.8. So we're getting almost to the value that we want to do. So 7 times 0.8, my math is horrible. So 7 times 0.8. So we're actually only rotating by 5.6 degrees. That is the first bit that we're doing. So now we're not completely reaching it within one frame. And let's say that then the next frame, we are we are now only what? So that is then +3. That's where we started. So we're 8. So 10 minus that. So we still need to rotate 1.4 degrees. We multiply 1.4 by 0.8, and we rotate by that much. So you can see that we're slowly approaching our target angle. And that is assuming that our target angle doesn't change. So if our target angle obviously moves all the time. Hey, Christian Bachelor. Thank you for joining. Cool, having a member on the chat. That's the first time that I see it actually come up like that. That's really cool. Hope you're enjoying the stream. So anyway, we are talking about how the PID controller works and explaining that, you know, if we just use our proportional gain and assuming that the target doesn't change, we will slowly approach that target. We'll never get there exactly. Well, if we do a value under 1. If, of course, we have a value over 1, we're going to overshoot, and then we're going to oscillate back, and we're going to overshoot, we're going to oscillate back, overshoot, oscillate back. So that's kind of how that works. It's also why you always tune the proportional gain first, because you obviously want to get as close as is comfortable to that behavior. And again, with a static target angle, kind of gets, but once you start moving, you want to make sure that you get that more smooth movement in there and get it to where you want it. And again, for us, where our input value and our output value, that difference isn't actually the output that we want. We want a magnitude of that output because we're actually applying a force. Our proportional gain might be much higher than 1. It might be 20 or 30, even though that might not be the strength to get to that rotation. So the second part of our PID controller, the bit that we cannot use for our angular solution, at least I don't think so, is the integral gain. So what you're seeing here is that we're actually calculating a factor of our error, and we're accumulating that. So in this case, again, let's say that we had that initial difference between here of 7 degrees. We're multiplying that by our delta, so how much time is passed. So we're now getting a value that says, hey, let's again say that we are going to leave the integral gain on 1. And let's say that we have our proportional gain on 0. Basically in this, we would start initially on our first frame by rotating it just the amount of degrees that it would take, that we would reach our end in 1 second. However, we are accumulating that in the integral stored value. So the next frame we come back in, our error is now slightly smaller, but we have our previous value stored. So now we're going to calculate, okay, again, times delta. how much would it take to do the remainder of the rotation within 1 second? Okay, how much do we need to do this frame? That much. I'm going to add that into our previous value. So the longer it takes us to get there, the faster we are going to start accelerating to that value. Now, the problem is that once we reach the value, our error now is 0, but we still have a stored value. So we're going to overshoot, and then we're going to slowly slow that down, and then we're going to come back, and then we're going to overshoot and slowly slow down. So the whole idea is that you use your proportional gain to get as close as possible, and then you're going to use your integral gain to push it closer to that, but in such a way that eventually it will dampen out. Now, the reason we can't use this is for the reason that we were talking about a minute ago here. Same reasoning for our velocity, because we are working with a localized angle and rotation. Whatever we will have as a accumulation of that value will not be something that makes sense. So probably we could local or rotate it back to global and then maybe do something to properly even that out. I am not sure. Might be possible, not completely sure. My math of this is not good enough. But so far, everybody that I've looked at doing this sort of thing in their code examples, they leave out the integral. So they basically have a PD controller instead of a PID controller. So yeah, not quite sure what we're going to do with that, but we're going to leave that alone for now. So we will keep that on 0. I'm not going to actually remove the code. I'm just going to keep that on 0 for now. The last bit of a PID controller is our derivative. Now, our derivative has 2 modes by default, and we're actually in this case going to remove one of the modes because we're always going to be working on velocity. So we're either going to do our derivative based on the velocity or on our error rate of change. So on our velocity, we are going to look at how fast our value is currently changing. So in the case of rotation, how fast are we currently rotating? And we're going to take a factor of that. And that usually works as a dampening, right? So take our situation again, where we're going from 3 to 10. Let's say that we ignore our integral. Let's say that we set up 0.8 for our proportional gain. Let's say that we do a crazy low proportional gain, like, I don't know, 0.5. We halve it, right? So we're going now from 3, instead of from 3 to 10, we're now going to go from 3 to 6.5 degrees. And that gives us a velocity. We're now rotating at a certain speed. So the next frame, we're going to go from 6.5 or try to go to 10. So now again, halve it. So that is, God, what is that? 10 minus 6.5 is that divided by 2, 175. So that becomes 7.5 plus 1.75. So we're now going to 825. But now because we had a velocity and we're applying our derivative gain, we're actually going to add a little bit more to keep that momentum going. It's actually not working as a, well, a negative value would work as a, yeah, because we are going negative. I knew it. That's right. So, interesting. That might actually explain. I wonder if that is something that I copied off of this code, or that's actually something that's wrong. Because in this case, I'm looking at my current velocity and I'm adding my derivative gain, which means that, you know, like I said, you get a dampening effect at that point in time. We were going 6.5 degrees per second. Well, probably a lot more because obviously we did this in one frame. Again, a reason to make this lower. But we would be adjusting it in that matter. So it would then, you know, because it's taking a negative value, it would actually be doing that. Now, the interesting thing, of course, is that the other option is going through error rate of change, where we're actually looking at the velocity differences from one frame to the other instead of the actual velocity of the object. I'm not quite sure why. It gives another sort of dampening effect, but whatever. So we're not going to support this anymore. We're purely going to work on that. But instead of having the value rate of change come from here, and interesting enough, you can see that we're dividing by delta here to get our rate of change in rate of change per second. Obviously, we are going to be sending it the velocity from our, have I still got it? Yeah, our angular velocity from our object, which is already in rotations per second. So we need to remember that. We're actually going to be using our velocity as is and just applying our derivative there. So yeah, that's going to be interesting. Okay. Right. And that also reminds me that, yeah, in ours, we always, our PID value that we're coming back with is then the input per second, and therefore we multiply by delta again. Some of the PID controllers that I've seen implementations already do that in the PID controller itself. Because we're using this code, we're keeping that outside of it. So yeah, with something like the velocity, you would sort of divide by delta and then multiply by delta again. But, yeah. In this case, because we don't have that divide, we're fine. So that's all the things that we're doing here. So here, yeah, just proportional is direct application of our change. Integral is our accumulated change, and derivative is our change based on current velocity. And then interestingly enough, as a negative, so we're always applying this as a dampening effect. And then we just add those together and there's our value. That's really what the PID thing does. And by just changing up how much of each of those you take, because that's the gain, right? It's basically, it's just a factor. How much of that part of the equation gets into my output. I get a value output that has an effect. So my poor man's explanation of how PID controllers work. All right, let's start changing this logic. And I'm going to start by changing this PID controller. And for now, I am going to work on the assumption that I can safely use the encoded value for this and not having to split the axis angle location. So again, that's wrong. That's something we're going to change in a minute, but we're going to rewrite our angular PID controller with the assumption that we can use a vector3 to do this. And we're going to go do that over here. Now that also means that for this, I no longer need my difference. We're not going to call that calculate Euler. We're going to call that calculate angular. Is that? Actually, you know what? Well, let's just calculate vector3. I don't like that name. Let's do angular. So we're not going to have a current angle anymore. We are going to say delta angle. Let's actually also go and put in a apply our PID logic. Logic. We're going to leave out the I to a axis angle value. So we're going to do our delta angle. How much do we need to change? And we're going to have our angular velocity as an input. All right, cool. So basically our delta angle is our error. So we no longer need U. And we're going to say our P is simply that. Cool. Now, like I said, we're not going to do our I term. Let's go and actually do that. We don't apply equal gain here. And then we're going to go for our D term. All right. So in this case, we can take all this out because we're simply going to add our angular velocity here. So in this case, we're going to say negative of angular velocity. I'm just going to keep that negative in there. I'm not quite sure if that's smart. I'm going to keep that negative in there to change our rotation. And we're going to just multiply that with the derivative gain. Now, here's another little thing that's interesting. When I look at a lot of the example code that we have, instead of tweaking the proportional gain and the derivative gain directly, they're actually applying a formula to create the proportional gain and derivative gain. And yeah. Now, the other thing that I'm wondering about is if this actually should be multiplied by delta or not. I actually think that is, because that is something that is kind of interesting here. Because that's the other thing that I've seen a lot of implementations do, which would mean that our derivative gain would be a much higher value in order to get the same sort of momentum. But because we're really applying, it's kind of like with gravity, right? When you add gravity in, you get an acceleration that way. Over time, is you want to have that acceleration be time independent. I'm gonna do that. I'm gonna assume that that is something correct that I have seen. And we're just going to go and put that in there. Why is this? 1 second. Just want to see if there's anything. Nope. No, not important. Okay. Value. So yeah, that's a maybe. Might need to take that out, but I think that actually will make this better from a frame rate perspective. Even though that obviously our FPS is kind of stable anyway, but whatever. All right. So now in here, obviously we're going to now calculate angular for that. And obviously our target local is still the same, but the question is now, can we use basis for this? All right. We got that. That's not right. And that's what I thought is, even though we can create it from a vector angle, we don't actually have a way of doing that. But we do have that in our Cortinian calculation. We have our get angle and axes, so we can get that from there. Now, the question here is, do we therefore convert that to Cortinian and then get our axes from there? Or, yeah, no, I think we're going to do that. Oops, that's not. There you go. I believe that I can create a Cortinian from a basis. Yep. So our basis here, what we're doing here is we have our target. So what is the orientation that our hand needs to be in based on our controller? We have our global basis, which is our current orientation of our hand, and we're inversing that. And multiplying these two together, although they might need to be the other way around, I always forget. It might not even matter actually for 3x3 rotations. But we now get the delta rotation to get to our target. So that is what that target local is. And you should actually really call that, delta rotation or something. So now we're converting that to a quaternion notation, which now allows us to get our target axes. Target Get axes, and we need to get our target angle. Now, when we look at those functions, I'm going to assume that that's in radians, because that's another thing that I've seen is a number of engines are returning that in what you call it, in degrees. And interesting enough, sorry, the angle here. Returning must be normalized. Returns the angle. Well, that's something that we can probably just put in there just to be safe. It should be normalized, but I've seen a lot of implementations actually multiply the axes with a degree to radians conversion. I think they actually mean that they want to be that, because they multiply that by that to get the value that we're actually using. In our case, I'm going to assume that that's in radians. Also not going to assume that that's not already normalized. So let's make sure that we normalize that, which now means that we should be able to say that times that. All right. Now this one is going to be easier because here we simply do angular velocity. We already have access to that. All right. Okay. So in theory, that should already be an improvement. Don't know if it is, but should be. Okay. So the next thing that I want to do, go back to here, go back to our PID here. That one doesn't matter. That one doesn't matter. I'm going to make that nice and low because I have no idea if our values are anywhere near what we're expecting them to be. But the big question is our rotation now going to make more sense? Now, I don't know if you guys remember this from yesterday's stream, but one thing that I noticed was that if I move my hand, it was first moving in one angle and then in another. And that's because of the way that the other angles sort of break the angles up. Because that actually gave the wrong axes to rotate around. But it's close enough that it kind of does the right thing, but it looks really weird. So with this, and especially because we don't have our derivatives set yet, so that is actually not being taken account. We're purely working on that one. We should be seeing a nicer rotation to our new value. All right, now I've noticed that SteamVR has kicked the bucket again, because of course I haven't had this on me for a while. And that way I'm really looking forward to something that I can't talk about yet. Because one thing that I hate about this type of headset is it's a pain to keep on my head while I am not using it. Okay. So, and what I mean by that is this. This is really uncomfortable. But this way, at least I can see my screen without the headset actually going off. So I should now be able to just play this. Let me move that over here, and then I am going to get started like this. Okay, so trigger to continue. Okay. Now it's not rotating at all. Thank you. So that is surprising. Because I would have been expecting at least some input. Now, that's of course very possible that we've got it so low that it doesn't work. So let's crank this up to 10, see if it makes any difference, or whether we have really screwed this up. Actually, I am going to keep this like this now that I know that this is good. Okay, so yeah, our value was probably way too low. Ever. Sorry, I do need to see it because I can't see it properly there. Okay, this almost looks like we should not be rotating in local space. Although again, we should be having an amount of rotation. I think we need to have some helper information here so that we can see what we're doing. Alrighty. All right. Oh, we have a whole bunch of debug errors in that. Those might tell us what's going on. Physics basic. Oh, go away. Must be normalized in order to be cast a quaternion. Use get rotation quaternion. Oh, that's actually nicer. Let's do that. Get rotation quaternion. Let's do that first. But the other thing that I want to do we also need an actual angle of rotation. All right. Let's see if that makes a difference. Okay. All right, so our factor of 10 is way too much, but also we are only rotating around one axis now. Again, it might be because we are doing our rotation locally. Okay. Well, let's try that first. No, I need to do that the other way around. That will make it global. I'm also going to make this low again. Let's see if it now... Oh, you guys can see that. Sorry. Forgetting to move that into view. Nope, that does absolutely nothing. All right. So it might not have anything to do with local. All righty. Time to do some visualization of this stuff and see if we can get some help in knowing what is going on here. Okay. So I'm going to assume that that is not correct. We're going to give that a little bit more so that we see it changing a little faster. Yep. So let's go and add a debug thing. Same thing. I'm actually going to take this off because that's too uncomfortable. This is going to take a little bit of work to get there anyway. You're probably going to exit again. Okay. So what I want to do is I want to visualize these two. We're going to do that a little bit different than yesterday. Because the angle we're going to print on a little debug label. But the axes we're actually going to draw. Alrighty. So let's start with dang, this script is big. That was the signals. Blah 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 blah. Have I already got some debug information here? I don't think so. Okay, here we go. We put that on here, I think. Well, let's go all the way to the top here. Actually, I want to get it from the other one. Which was the other one that we did? That was on this movement script. Here we go. All right, there we go. Start with our axes. So on our controller, there we go. Show debug info. Perfect. First thing is in our vars, var rotation vector. Okay, and the thing that we're going to add on, again, I'm going to just add it in here for now so that it's easy for me to see. Oh, I don't have those in here. Really? I thought I had. I may not have done that here then. Okay. Give me a second, and I shall. Really, dude? All right. Let me just copy something over. Projects. There we go. I think I've got it in here. I think I might have only done these as no. Did I not put them in here? I did not put them in here. Okay. Or did I put them in here? Nope. Okay. So where did I use that again? My tutorial video. That's probably where. Yep. Okay, we're going to copy all of these. I'm going to complain about that, but that's okay. We'll fix that up in a minute. So where is my, sorry guys, I'm just doing this off screen at the moment. I'm just getting some classes that I had. And we are going to I'm just going to create a debug folder. I'm going to put these in here. Okay. Now, let me go and just open that in here. Remove the building UIDs because I wanted to create new UIDs or else we're going to get in trouble. And I need to change the folder here. So this is going to become add-ons. Do export tools to debug. Okay. Now let's go and copy that because I also need to change that in here. So that one and that one. And again, the same thing. I'm going to take the UIDs out of here. It can calculate nice new ones. There we go. Or else I'm going to be in trouble if I ever put this into the same project. Okay. So with that, yeah, that's right. I'm actually going to comment out this thing for now because I want to make sure that these scenes are good. So this is a nice little helper scene that I made that I can drop in things where I have a label and I have my axes that I can show. But I also have a axis itself that we can easily position with a look at. So we can go and visualize that. So in this case, we're going to use that one. And I'm actually not typing this. Okay, that's interesting to know. So if we go back to here, that just becomes that. Cool. All right, so now, nope, here. We need to go to process. Yep. So what we're going to want to do here is if debug show info, else if in this case, if we have that, we're going to say visible is false. We're going to hide it. This. Okay. And of course, in this case, we're going to say true. And here we're going to say, if not, then is, let's just use normal load. That, and we want to have our vector scene here. We're going to assume that works in this case. So new. And then we're going to do obviously add child location vector pulse back. There we go. I'm going to leave it on white. That's fine. And what we want to do now is I'm just going to do that on the transform itself so that we know that this is going to happen locally. Looking at, so because it's local, let's make sure that we add that in. Plus our target axis. So in theory, that should give us a visualization of the axes that we are going to rotate around. Now, we are going to go and probably make that a scaled axis. Because else it's going to be a 1 meter long one. That's probably a little bit overkill. So, yeah, let's make it 10 centimeters long. That should stick out of my hand far enough, I think. Okay. We are still working, by the way. Go. All right, ready to test this. I'm just thinking that this probably needs to have a vector. We go up. And I'm going to assume that I need to make that true, but it might actually be false. I always forget that bit. All right. So now we should see a vector around which we would expect our hand to rotate. And as we move our hand away from where our thing is, and actually I'm going to go and disable, I'm going to disable our applied torque. So our hand should remain in the position that it is, so that we should be able to really see whether that angle makes sense. Okay. Oh, forgetting. Where are you here? There we go. Okay. Oh, and I forgot to turn it on, of course, didn't I? Yeah, forgot to turn it on. Nice. All right. Okay. So character buddy. Nope, main. Okay, so that's here as well. Okay. Try this again. Let's see if that vector is anywhere near where we expect it to be. I'm hitting a breakpoint, am I not? Yeah. Non-existent function new. It's because that needs to be instantiates. This is why I should probably have done that nicer and code that properly. Maybe I will change that and clean it up later. Okay. Really? What am I doing wrong now? I don't think that's going to be visible, is it? I don't think it shows. It might. It shows this. Oh yeah, that's my collision shape that I created. Interesting that that's actually in there. Oh, I'm guessing that the other ones I'm not actually creating as internal ones. So here we can see all the. Oh no, it's here. Look at that. I thought it would hide that in here, but it actually shows it in here. That's nice. So that's showing. So, did I really just make it too small? Go away. Just take that out. So now it's full scale. Let's see if we actually can see something. Oh yeah. So why? Did I pre-scale vector? Is that why? Vector. Oh, I did. Okay. I only made it that long. I thought I made it a meter long. Okay. That makes sense then. Okay. Well. Let's see. Come on, let me see it. Oh. That's the other problem. This is what you get when you by the way, hand tracking. This is what you get when you copy things from another project and then forget how the other project is set up. Because the thing that is missing here and that I actually never implemented in this is yeah, I put layers in there. Oh, let's complete that because that is much nicer if that works properly. Did I close it? I did. Cool. Yeah. Yes, I did. Export. That is Black Studio Render. Var layers is, I'm going to default that to 1. Yep, so there's my layers. All right. Set value. Layers is value. It is inside tree on layers changed. Boom. Give the function. Boom. There we go. So in here, them layers. Oh, not. Look. And head. There we go. So we get our layers nicely set now. Perfect. And I actually want to do that in, because I know that we're not using axes yet, but we will eventually. So we're going to put that in there as well. And let's go and make sure that we've got a scene open so that we can see what we need to do. So func, boom. And oh. Oh, here I didn't have the on in there, so let's be consistent. Let's be inconsistent between the two classes and consistent in naming in one class. So here's a bunch of things that we need to do. So the first one is forward z dot layers is layers. Then up y dot layers is layers. X dot layers is layers. And label dot layers is layers. Okay. So if I end up using the axes, then layers with value nil on base. Why is that complaining? Vector. Is that something that was wrong and we just did that right? Probably. Clear. Just want to double check if that is indeed a problem or not. Not happy about that. What's it in here? Just a dumb. We really need to get up. Yeah, we still get at this because we're on 4.5 here. That's supposed to be fixed in 6. 4.6. Okay, so with that, we should be having all of that. I do not care about my table right now. And I now should be able to see what I was doing in my headset. So now I can see it too, and not just you guys. I hope. All right. Does that make sense? Maybe I should make it a bit longer, though. I'm just going to get a little bit closer so you guys can see what we're doing. So if I'm moving this close to each other, as I'm rotating this, I'm definitely expecting that arrow to change direction quite a bit. Because when I'm like this, I'm actually right in the same spot. But then I can imagine that there's not a vector that's usable. But then when I'm obviously turning around this, I would now expect that vector to be pointing up because we're going to rotate around that up. So our rotation axis is definitely not what we expect it to be. Huh. Why not? It really looks, to see how it looks like it's almost constant. It's just a little bit, but definitely that should change lots as I move my hands. So something's not working here. Now I hope that doesn't mean that our logic in Godot isn't good. But right now, we are not getting the value that we are expecting. Or this code doesn't work. That's also possible. But I think we've done the right thing here. I want to go and put the scale back. But obviously not 0.1, but we're going to scale back 2. Just so that the vector is a little bit longer, a little bit easier to see where that's going. I think pretty sure that the transform is going to stay 0, 0, 0 because I added it there. We're just doing a look at different. And again, this might be false. I'm always forgetting about that. Oops. Well, let's double check that first. Just for testing. That's a good one. For that to work, for us to see whether that makes sense, is just purely on this one. We're going to add a vector on here. There we go. Okay, so that is pointing default to there. Okay, so our up, remember, we're going to have that in local space. So our up should be that way. So that's green arrow. Let's actually make sure that this is a different color so that we can tell it apart. Don't really care about the color, it's just a helper. We just want to see that our white arrow is going in that direction on our hand. That will help us determine whether I have done this right. If it's down, then that false needs to be true. Let us see, let us see, let us see. Well, it's kind of correct. It's actually, it is up. Just remember that with hand tracking, we actually have our hand oriented like this. So our skeleton is actually creating that rotation of the hand. So we're actually like this right now as far as our our transform is concerned, but because the hand is then positioned like that inside, we should actually rotate back that way. Anyway, the point is the up is pointing up and it's pointing the way that it should. So that part of it is good. Now we need to figure out why is our rotation not the way around as I expect. All right. So no longer need you, Mr. Helper. Goodbye. No longer need you. I know that you are now being positioned the way that I expect you to be positioned. Let's leave that out for now. So now, what are we doing wrong here? So, okay. I am actually going to start by overriding this again here, just to use it as a helper. There we go. What I'm going to grab is I'm going to take our target local. And I'm going to take our base. Is that it? Oh, wait a minute. Wait a minute. Yeah, no, that is already bases. Okay. So I'm just going to take the Y vector there. So what I'm doing here is we're looking at the delta rotation, and we're going to see our delta rotation, how much that is, how much the up vector. Actually, this one should be probably be an axis then. Huh. No, this is enough for me to go on, I think. I just want to see if our local rotation bases make sense. Okay. I'm going to cheat for a sec because. Okay, so I'll comment this out. I'm going to comment that out. Just want to get our axes, and now what I want to do is rotation vector dot transform dot bases is target local. So here we calculated our rotation, and I think what we're going to find out is that I've reversed those two. That's what I'm expecting. But this is our local rotation from where we currently are to where we need to be in local space. So in theory, that rotation should line up with my ghost hand. Let us see if it does. I did something bad. Nil on that. Why? There's his value. If inside tree, then do that. That should work. Coming from ready, so we should be ready. Why is it not like that? Okay, something's going on wrong here. Huh? Oh, what? And of course, I had that open. I forward is actually this one. Yeah. Why? So one thing that we're doing here wrong here, this actually should have that, but we need some more here. And that is good. Okay. Yep. But why? Does it not like that? Yeah, that makes sense. If I can't do that, did I do something wrong here? This is if inside tree, then layers changed, and we assign those layers. And in this one, when we then assign the layer, if inside tree, the layers changed. Well, I already saw that we got on the ready, which means that that should be. So did I do a typo here? That is called layers. Yeah, I got that. Stem head. Set layers. No errors. Changed. Why is that a problem? That makes no sense. Why are you giving me a hard time? All right, I'm loading that. I'm instantiated, and it's only once you do add child. In the assignment of property or key layers, the value of type nil based on here. What's that about? Oh, that works. It just had an issue. Maybe I just needed to make sure that some things were saved. Anyway, that is actually exactly what I'm expecting it to. And again, that is because, you know, obviously our hand is weird. So at this point, there's no rotation. So that part of it looks good. That I'm happy with. And let me move a little bit closer so you guys can see as well. See? So the axes are lining up with the hand. Yes, I know that the up points forward, but that is that weird hand position that we are getting the hand from from SteamVR with. But the rotation matrix is following the hand precisely. So I think our rotation matrix, our delta rotation, is calculated correctly. So we've ruled that out as a problem. That's progress. Okay. All right. Sweet. I'm just gonna leave this in there. I'm very tempted to actually add them both. But yeah, I'm happy with that. That looks like that is working correctly. Actually, let's do that. Yeah. Okay. I might not keep these in there, but for now, I'm kind of like, hey, it helps us debug stuff. Okay, so both to be visible. This now becomes else. Oops. If yep. There we go. All right. Let's see what we get to see now. So we should now have our axes, and we should have a nice little white thing pointing some direction. So, okay. So we can see that we've got that working. All right. So this should be, we're not rotating at all. And then, so if we go like this, so now I'm purely rotating around the X. I'm expecting that white arrow to either point up or that direction. So it's doing something, but you can see that if I rotate, so now I'm actually on the X. And yeah, I'm rotating like this. I would expect that to do so. Yeah, the rotation axis doesn't make any sense. That does not look like it's doing what it's supposed to do. Okay. Okay. No. Label. Oh yeah, because it doesn't do that. Okay. Just want to have it say something else than XR Origin 3D. Okay. So I'm happy about that. I'm not happy about that. And again, assuming that the target axis is correctly being applied. So we get our rotational quaternion, and assume that works. Returns the rotation axes of the rotation represented by this quaternion. Oh, we can abuse that for the label, for the angle. That's actually a good idea. So let's go and move that here. And say angle and 0.2 f. Rad dig target. Okay. Let's try that first. I want to see if that at least makes sense, or if that's also going to be a nonsensical value. Okay. So again, same thing. Once we get really close to this, yeah, so the angle makes sense. I'm going to 90. If we go like this, I'm going to 90. Oh, can't really move my hand that way. So yeah, it's not exactly 0, but I'm getting close where it will be the 0. Try and find where that is. So I'm still having some sort of rotation. I'm trying to get this close to 0 as I can. But it's, you know, I'm close to where I am. And when I turn like this, my rotation gets 90. So that makes sense. However, that axis does not make sense. Now the problem is I don't know whether that is because the rotation definitely doesn't make sense or because I screwed up. Because the fact that this axis doesn't do at all what I'm expecting it to do. To me sounds like, hey, maybe I'm not doing that calculation right. So now the transform origin here should be 0. You know what? I'm going to print that axis in here as well. So what we're going to do, I'm going to do a /n axes to f. All right. And with that, we're going to do target axes.x y z. So that will at least tell me whether we're just drawing the arrow wrong or whether all right. So when I do this, yeah. Huh. The axis is correct. We are not drawing it correctly. What? What the heck? Okay, what is the dumb mistake that I made in doing this? I am taking transform.origin, which is not the transform.origin of that one. I am going to assume that stays 0. I am just going to do that. And let's go and see if that works. What the? Oh, that is stupid. That was stupid. Okay. Okay. All right. So, see? I am actually, you guys can't see that. Let me go closer to the camera. Let's do this. So you can see that I have now rotated around the Z. It's nicely pointing upwards. Cool. All right, so now let's start with that. Say rotate around the, sorry, I was rotating around the Y. So now I'm rotating around the Z. I don't know if you guys can really see this. Oh, if I rotate that side, you guys can see. That arrow is the right way. So the last one is rotating around the X axis. Yeah, we can see that rotation arrow is correct. Our angle is correct. Our angle was in radians. That is correct. So that is cool. Okay, so this was always working. Okay, so our data is correct. Cool. All right, our data is correct. So now the question is, what are we then doing wrong? So I'm now calculating that. So let's. Let's apply our torque, but I'm not going to negate it. I'm actually going to rotate it according to that. Let's start there. Let's see if that makes sense. And I can't remember what we've put our pit to, but we're going to assume that that makes sense as well. So, you know, we might get the wrong order of magnitude, but we should be. Okay. It's just very slow. I don't know if you guys can see this. It's slow, but it's going where it needs to go. Oh, that's cool. I am happy about that. Okay, that is really promising. All right, so hop, hop. Let's turn up the heats, get our pit to be a bit stronger. Okie dokie. All right, we're faster. And we're getting there. But it's still nowhere near where we need to be. Okay, hold on. We can go and tune this. Okay, we should be able to live tune this. Let's make this 50. Okay. Okay, is that not applying it? Did I? Oh, what? No, still going slow. Okay, so our pit is not being applied. Did I skip the pit? Yeah, pit. All right, so let's just rerun. Maybe it just didn't pick that 50 up. That's very possible. Oh yeah, so I didn't live update. So that is okay. I'm going to click closer to the camera again so you guys can see. My hands still a bit on the slow side, but it's getting very close to what we want it to be. Okay. Now, even though it's slow, I want to see if this actually. Well, it's able to somewhat do it. Oh, go away. This is having more problems. But then again, this is a 2 kilogram thing. So, yeah, interesting. Okay. Okay. And this is where, you know, the Integral would be great because Integral would ramp it up if it's not enough. Because that's one thing that I'm worried about is as we grab more heavy things, yeah, that's going to be a problem. What is actually the weight of our hands? Oh, so this is what we would normally change for inertia. So with zeros, that is all. Torque. So yeah, with 0, the inertia automatically computed. Yay! I must be hiding the mass. I think I've got some code in there that hides stuff. Let's go to 100. Let's see what that does. Still laggy, but it's getting better. I'm able to move the 1 kilogram closer to normal. Which I can do this. This is already lots better than it was before. Let's get the 2 kilogram one. So I've got the same thing. I can do that, but the 1, I don't have the strength to do that properly. Okay, cool. Wing, 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 wing. I'm gonna crank it up some more. Let's go to 150. And again, we might end up, disabling the inertia. It is very possible that the inertia has got a problem with this. Yeah, it's time. I really need to make this. It's actually really still a bit on the slow side, but it's bloody stable. How cool is that? Okay. Well, still, bouncy. This is the thing that I want to prevent. This is what I'm not happy. I'm just moving my hand forward and back, and it's just dangling like that. So we need to have enough strength to counter that, especially for a 1 kilogram block. I can understand for this one that is just too heavy to hold. But for 2 kilograms and 1 kilogram, I should be able to pretty much keep that stable. Okay. Actually, one thing that I also want to do very quickly is I'll take that scaled out of there. I think that scaled is overkill. I don't really need it to be bigger. Okay. Oh, let's go to 200. And I might go and put some derivative in there in a sec as well and see if that works. Oh, that is good. Holy crap, that's good. That is almost no lag. Oh, and the 1 kilogram I can hold pretty well. There's a little bit of bounciness in there, but I can really hold that well. I like how I can shake it up and down. It goes wobble, wobble, wobble. About a 2 kilogram. So that's still a little bit too much. Okay. We're getting close, guys. I like this. This is really good. So I'm gonna actually go and do this to 250. And I'm gonna give it a little bit of derivative gain. I think the derivative gain needs to be way, way more. But let's see if that makes the difference. I really need sliders for this. I need to have some sort of UI that allows me to change that. So I'm pretty happy with that. Okay. Yeah, we need sliders to update this. Wing, 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 wing. Well. Huh. How about we add our first 3D control in here? Oh my God, I'm happy about this, guys. This works so much better than before. It's not perfect, but it is really close to good. Okay, so why does that feel wrong? It feels like I'm supposed to be like this when I'm like this. Why? I don't know. But yeah. Yeah, it's definitely having some problems in oh, maybe that's why. Because I actually didn't balance my grab points out properly. Oops, I hit my thing there. So because of where I'm grabbing the box, I'm grabbing it. It's like I'm grabbing it like, I don't know if you guys can see that, but I'm grabbing it off center, and the weight of the box is causing my hands to go like this. So now I'm trying to push it back like that. Huh. Yeah, we're gonna create some physical controls. I don't know where we're gonna put them. We're gonna create some physical controls with which we can control our oops. I really think that maybe I think that radius needs to be smaller. I don't like that radius because we're really getting towards physical now. Why does it keep falling like that? Ah. What the? You guys can't see it, but there's some text on here. And when I drop this, it is getting a weird momentum. I think that is because when I drop it, I'm actually colliding still with it. Because that's the other thing. I don't know if you guys can see this, but I actually, now I'm not grabbing it. I'm just pushing. Oh, there's something in my desk in the way. So it's not just that I can grab things, I can push things. And that actually works really, really nice. And I even, like this, I can just put my hands, and now I'm actually grabbing with tension. See how stable that is? So this is not grabbing with tension, purely on collisions. I'm not grabbing with the actual grab function. I am just doing that. So the other thing that I really want to do with this at some point with these boxes is that when I hold it like this and I press the grab button, instead of it snapping to my grab point, you can now really see really well that that it's not centered. When we grab, we actually do some sensing and we grab it on that point. Now I do have, because this right now has got, I might actually make another set of boxes for that. This has grab points so that we hold it at a specific location. But there is logic actually in here, or maybe I only put that in. I might still need to transfer that into here actually. But there is logic that allows me to, sorry, I'm just having too much fun moving this box around. But I do have logic where it will shoot out a raycast from the center of my hand into the box or into the object and try to find the closest point that I can grab it. And the thing that I need to do then after that is to not just grab it on that spot, but then move my fingers in a way that it actually sort of taps the object. So like an auto pose function, basically. Still something that I'm planning to add in here. But then for like grabbing a weapon where you really want to grab it on the on the proper place so that your finger gets into the right place. Yeah, I definitely want to have that to be VR with a desk. Yeah, I don't like that bit because I've got this logic where it snaps to where I am, and it's too aggressive. Anyway, we were going to add some physics interactions so that we can actually fine tune this stuff. Let's have some fun with that. That is actually, yeah. Is there a specific game's physics interaction model that you're aiming to emulate or inspire or be inspired by. Yeah. So the thing is, and I'm still a little undecided. Um, the thing is, in Xtra Tools 1, what we are doing when we are moving our hand is we're actually moving the hand object to exactly where the controller position is. And all that we are checking is whether we're colliding and stopping the hand from going through an object that collides. So I'm not able to go through a wall. And when you look at the little pushing around that I was doing, we have some logic there that sort of simulates that, but it doesn't do as good a job as a physics engine can do natively. So that was the first reason why I wanted to change things. The second reason why I wanted to go down this path is that in Xtra Tools 1, when you pick something up, we actually pair that object together. It now becomes a child object of the hand. And actually, that's where we started. Eventually, we started using remote transfer from this. But it basically means that the object that you're holding is just moving through space, and we're positioning it whatever the hand is. And while we have a little bit of weight simulation and stuff like that, it's not very good. And it causes a whole bunch of problems in positioning and in handling. Just go fill this back up. So one of the first things that I wanted to do and wanted to do for a long time was to replace that sort of logic with something that uses the physics engine more directly. And not just move the hand just with, move and collide so that it stops somewhere, but by moving the hand actually with physics like I'm doing here, so that it would properly interact with whatever it hits when it moves. The second thing that I really wanted to do is that when you grab something is to use physics joints, which I'm doing here, so that the hand and the object that you've grabbed works in unison, and the physics engine handles all the complexity of what to do, especially for two-handed. Like if you look at how two-handed is implemented in Xtra Tools 1, there's a whole bunch of extra logic that we're doing to make sure the hands are positioned in the right place and the object is rotated in the right way. Here, one hand on one side of the object, one hand on the other side of the object, and we're just applying forces, and the physics engine just figures out what the balance is. So I know you asked for inspiration, but this is the reason why I wanted to go down this reason. The inspiration for doing this is, first of all, other people who have experimented with this, but also looking at games like Sword and Sorcery or Boneworks / Bone Lab that have gone to this much further along than we do. Now, I'm of two minds, because one of the problems that we're having with this approach, as we have been trying to solve the last 2 days, is that because we're using the physics, getting the correct forces to be applied to a hand, especially for rotation, has proven very difficult. And this is because when you move your hand in real space, / when I pick something up and I move my hand in real space, your brain is a very powerful thing. It is not just moving your hand, it is automatically correcting your hand's forces and applying the right forces on your hands to move. And in the physics, we're doing the reverse of that. We have as input how much your hand has moved. And in this case, we have the input of how much our hand has moved without the hand actually holding something. And we are now trying to figure out how much force to apply to the physics body in the engine that represents the hand to make sure that the physics body hand moves the same. Yeah. Hey, push. That sounds really nice. but it causes a whole bunch of problems because obviously the amount of force that you need to apply to move the hand from here to there is completely different if your hand doesn't hold anything and when the hand is holding a very heavy object. And here's the really funny thing is the physics engine is actually taking some shortcuts, and we actually found out that the moving the hand somehow magically works. Even though I'm not increasing the force, I'm actually applying the exact force needed to move the hand without anything in it, and it moves the same when it holds something that is 20 kilograms in weight. But the rotation, it is actually doing the right thing. So the moment that I pick something up, all of a sudden I have an angular force that is pulling my hand down, and now I need to increase the force that I'm applying to my hand to keep the hand near to where I want. But it's a much bigger force than if I need to move my hand like that when I'm not holding anything. So getting that balance right and getting that to work properly is turning out to be a challenge. Now, the PID controller is supposed to take care of some of that, but we may end up eventually having to do a little bit more to counteract when we're actually holding things. So this is already working way better than it's ever worked before. So I think we're getting close to the right answer for that. And if so, we now know that we don't need that. If so, I'm really happy to go forward with this because this is the other reason why I wanted to go down this path. And, you know, this actually has nothing to do with the inspiration side of it. But the moment that we are doing things with physics joints, when we pick stuff up, all of a sudden, everything comes simpler. And we'll see that right now because I want to build our first interactive object. And you look at Extra Tools 1 where we have that. We have lots and lots and lots of logic to make that work. Drink a bit. And that sometimes makes it really difficult to make it properly work. In physics, if we're using physics properly, then the physics engine does it all for us. So let's go and see if we can create a slider that we can move. And then obviously, as we move the slider, that slider is going to start changing our proportional gain. And then we create a second slider that is going to allow us to change the derivative gain. But instead of the sliders being 2D UI elements that we interact with, let's make a real 3D object for that. Excuse me. The startup I'm just going to do in our main stage scene here. But eventually I'll probably make that a proper component. And because we're eventually going to probably make it a proper component, do I want to have... Oh, that is a nice idea. Sorry, guys. One of the problems that I have is that we're going to make a more complex object right now. But we want it to be reusable. So normally we have a bit of a problem on how we do that. But I just realized that we can actually, we can actually probably make something nice out of that. Let's for now just make it work and figure out a nice way to make it more editable later. For now, we just want something that we can do. Oh, is that still in there? Hold on. Sorry, small detour. Want to find out where that is because that's no longer part of our scripts. Okay. We left something. Find as files. Find. Let's just be offset. That's how we now do that. That looks like it might be actually something behind the scenes. Side check. Huh? Say what? Why would that be set like that? What are we in? Main stage? So in a main stage, I have a head here. And somehow we have that. Why? Don't do that. And why is that even pointing to something? Why would you do that? That makes no sense. Must be a little trick there. Whatever. At least the neck is gone and that error is hopefully gone. So let's just reset that and that should be fine. Anyway, we were trying to do this before we got rudely interrupted. So actually I want to change type of this. We're gonna make that a static body. Okay. So because we don't want our slider to move, our base of a slider is going to be a static body. So let's start with that. And I'm just gonna, for now, I'm just gonna move it on a table here. And again, we just somewhere over here like that. All right, yeah, that's okay. So we're gonna go and add a collision shape to that. And we're gonna add a mesh instance. And you know, this is kind of where, you know, the thing that is important there. And in this case, the collision shape doesn't even matter. We just need that there because we need something, you know, to work with. Let's just make that a box. And then not so big, smaller. Just what is it? No, not shift. Control, no, alt. I love that they've made that possible. That you know, that it only drags one side and then it repositions it. However, I really wish that it was a little bit clearer that you could do alt and then drag to only move it the way that I just did. Okay, I think it's still too high. I want to actually make that a lot bigger, smaller. So let's make it 0.5 centimeter high. And again, I don't think this collision shape is important, but I just want to match that up with the box shape that we're going to create here. So here we go, box match, and I'm going to make that the same size. So I think that was 0.5, 0.05, and 0.1. There we go. That now fits into that. So the reason why I'm saying that I don't really care about the collision shape for the slider is it just forms a base of our object. And we're not actually interacting with the static body. Static body is just an anchor. What we are going to interact with is a rigid body. Actually thinking that, so this is 5 centimeters. That is actually still, I think that's way too. I'm just going to make that 1 centimeter. I was thinking of millimeters, but it's centimeters, so 1 centimeter. And then this can actually be 0.5, and then this can be 0.5. You know, one thing that we could do to be really funny is make this a rigid body as well, so that it just falls down onto the table. But then our slider could, as we slide it, transform some of that force to the actual slider body, and we could end up moving that. But okay, nope, I don't want to do that. I need to move this one, so I want to just make it a little bit over here. So there we go. So basically, just forms a base for us to work on. All right. I also want to have a material for this thing. So shader material, and then I just want to do a textured shader. There we go. Hated that it always goes to the wrong thing there. I hope that's actually fixed in 6, but might even be fixed in 4.5.1, but I'm still on 4.5 for some reason. So here we go. We have that. We have that. We're going to do our little pattern like that. Again, same thing. It goes back to the wrong selected object. There we go. I just want to have it a little bit of a thing. Let's give it a bit more of a gray color. Let's move the roughness a little bit down. Not that that really matters, but we have a base plate for our slider. Yay. All right, so now we need a thing that we can slide. So for that, we're going to add a rigid body to this. Okay. And I want to move. No, I'm going to keep that rigid body over here for now, but I do want that to be a bit up like that. And we might position that a little bit more. Well, we actually will position that a bit more precise. We're going to put that at 3. So we do know that we're half a centimeter off the base. Which actually, I would like to do that like this. 0.05. I'm going to do that with this one as well. I've just made my transformer favorite, so that's why this is at the top. I don't know if anybody knows that yet, but any property in our tree here, you can right click and you can favorite the property. And then that property will be moved to the top of our list. So you can see, hey, I've got a favorite there. So the reason I did this now to 0.5 is that now when we go into the slider, we see that that is on the bottom of our object. So move it down a bit. So if I move that nicely onto the table, then everything is counting upwards. So now with our rigid body to 0.03 as a center, I can add a mesh instance to this. And I'm going to add a cylinder mesh to that. Ooh, that is way too big. And because we have 1 centimeter, we're now actually 2 centimeters above. So we want this to actually be 4, 2 below, 2 up. And then obviously we don't want this to be super, super big. So let's just go like this. This might be too small. You can always make it bigger. And we have a little pole there. Obviously, if we nicely model this, we could put a nice groove in our slider thing. Don't really care about that right now. I just want to have a nice little sticky thing. Cool. So let's call that stem mesh. Now I also want to have a collision shape for that. Stem shape. And that is then going to be a capsule shape. That's going to be the same radius. That is going to be that. And the margin is freaking impossible here. So we're going to just do that. All right. Didn't I just create that? I guess it was just being annoying. That's the other thing that I want to do. Settings. Thank you. I can zoom in a little bit better. Yay. I'm thinking maybe we need to make it a bit bigger. Also, that doesn't look like it's the full size. Did I type that in wrong? No, 0.05. Oh, because I've made it a capsule shape, you idiot. Cylinder shape. Thank you. Let's try this again. 0.04, 0, 0, 0.1. And actually, I want to make this a bit bigger, so I'm going to do like that. And then I'm going to do the same thing here. There we go. So that's a little bit bigger now. No, I actually liked it when it was smaller. 0.5. 0, 5. Um, 0, 5. There we go. So now we have a stick that we can move around, but I also want to do a nice little circle on top of that. So start with a mesh instance. All right, not mesh. That is going to be a sphere. Where are you? Sphere. Where's my sphere? I'm blind. Can't see. So obviously we want that to be a little bit bigger. We want that to be like that. Maybe a little bit bigger than that even. 3. There we go. And now this needs to be up. Too much. Oh yeah, because we're going from the middle. There we go. I think that's actually too big. There we go. So we have a nice little knobby thing that we can grab. And obviously we also need to have a collision shape for that. So we can put multiple collision shapes under a rigid body and it will combine those. It's really nice to know. So again, we're gonna go and do a sphere shape. Actually, it's already closed my. I hate it when it does that. So what did we say that we had it on? 0, 1, 0, 2. Okay. 0, 1, and actually that is always round, and then obviously that needs to be like that. So there we go. We now have a nice collision shape around the top. All right. Cool. I just for fun want to run this. This is not complete yet, but what we should see right now is that first of all, that knob will fall over. But second of all, we should be having some other sort of fun. Okay, let me just restart SteamVR. Or sorry, Steam Link. I get that you want to save battery and time out when I'm not using you, but it'd be so easy if it would just keep running. Okie dokie. So. All right, here we are. Actually, that looks way smaller than I thought it would be. I can now grab that and well, it's in definitely the wrong spot that I'm grabbing it, but yeah, obviously it's now a separate object that has nothing to do with our slider. It's definitely way too. Oh, I just dropped it on the floor. It's definitely way too small, so we're just definitely going to scale it up a little bit. I think I'm going to make it about twice as big. But obviously it's not attached. It's not doing anything, but I just wanted to make sure that that bit works. We're also going to go and take our debug info off because we know that that now works. So let's go and have a look at making this work a little bit more. Always funny when these things happen. Okay. So we're going to make everything twice as big. That means that this is going to be moving upwards a bit. And with that, we're going to make that 1, 1, 8. Oh, sorry, this actually needs to be 5. If it is 6, do we get a gap? Yeah, we get a gap, so that should be 5. So we obviously need to make this bigger, so that's going to be 8. It's going to be 1. And so now that is 5 plus 4 becomes 9. That becomes 2. Becomes 4. I want to make these a little bit less because that's way overkill. Now, obviously, that's 9, 2. Obviously, this margin needs to be less. But I think for these, the margins don't really matter. That is definitely wrong. Because it's from, yeah, so that's just 4. I'm overthinking the positioning. I'm thinking about positioning above the slider, not from the rigid body. All right, so that's a little bit bigger. It looks way bigger than big, and shadows we need to do something about, but not today, not right now anyway. It almost looks like my bar doesn't support shadows. Interesting. Maybe it doesn't. Maybe that material actually doesn't. Oh, because it's the same materials for this. No, it's the. It is definitely the precision of my. I hate it when I see that one because then I want to immediately go and tweak that. Those are good. Because the thing is, our bias is 10 centimeters. All these settings are always they're always good for normal games, but we are a VR game, so everything is in physical units. So there we go. That looks way better. Now our shadows actually look like they belong. Yay. Okay, cool. Little distraction there. So now we have a bigger rigid body, but we still have the same problem as before. And actually, it also reminds me there was another thing that I want to do. First of all, turn it off. But second of all, my range is way bigger than I want it to be. So we can see that we've made our hands 0.4 kilos, whatever. So where did I teleport distance? No. Appearance. Nope. Oh, because that is not my hand. That is my pickup function. And I want that to be a lot smaller. Yeah, maybe a little bit more. Nah. I want it like that. I'm wondering. No, that should stay like that. So, okay. And we got it with this one too. There we go. And then here as well. Let's turn our debug info off. We now know that works. I don't want to remove the debug info stuff because it might be coming in handy later. But okay. So a little instruction here. Let's go back to our rigid body. So I could now pick up my rigid body, just like before. It's a little bigger, but still. And then I can drop it and stuff. What we want is for this to be restricted to slide that way and nothing else. So what we're going to do is we are going to add a slider joint. There we go. Cool. All right. And what we want to do is we want to have a node or two nodes that are going to be linked together. So obviously our base node is going to be our slider. And our second one is going to be our rigid body. And that means that these two will now be restricted by what we're saying over here. Now we have an angle limit. Hopefully that is all zeros. Perfect. And we have a linear limit. Now, one thing that is important is that this is going to be in a certain direction. Now, I remember that this actually is reversed, but whatever. But it should mean that we can now only move in that and that direction. We can see that we have that to being a little bit big. Now, how big was our slider again? That's its position. No, I want the size of you. Half a meter. So we can go 2.5 that way and 2.5 that way. Cool. All right. So let's make that 2.5 and minus 0.25. And with that, in theory, we should not be able to move this outside of that range. Let's see if that works. Hey, Rodslams, how you going? Nice of you to join. I'm doing great. I'm finally starting to get to a point where I'm happy with how it works, which is really amazing and kind of not something I was expecting. So let's see where we are. Come on. There we go. All right, there we are. So I can now go over here, and I should actually even be able to do this. Ooh, that is not completely happy. Wonder why it is doing that. We definitely need a damping, but I don't know why it does that little rotation thing. There's definitely a problem in the rotation. Should not be doing that. I should also be able to grab it, and we can see that we can now move it backwards and forwards. You can move it a little bit weird. This is where the constraints just are a bit weird. To figure out how we can stop that. But I can move it around this slide thing. So yeah, not quite happy that I can do that. This is one of those things where the physics constraints are just, my hand is so powerful, I can really overdo that. And again, also I don't obviously have a proper position for this. So one of the things that I also want to do in here with decorators is that when we do something like that, is that because of the way that works, is that we actually position the hand on the thing. But yeah, we definitely need to figure out, like, why is it allowing that? Because that makes no sense. Now, also, I think the reason why it is sort of floating above is the margins. This is something that I've noticed as well, is for some reason, sometimes the margins, it's bouncing around like crazy. The margins actually extend out of the object. So let me go and look at this. We have that margin here. Well, that's only a millimeter, so shouldn't be doing anything. I don't know. This is where physics in Godot do suffer sometimes. Let me double check if Jolt's actually running. It should be, but no! How dare you not be on Jolt? You're supposed to be on Jolt. Okay. All this time I've been working on the built-in physics engine. That is not good. Custom solver bias shades not supported. Yeah, that's fine. I don't care. I just why? All right. So this could be interesting. That would fix a number of other things as well, or screw everything up. So let's see how much we've broken. Let's make sure that everything still works. Okay, our hands still move. We can still move. I can still turn. Can I still do this? Yep, I can still do that. Does this still work? Yeah, I can still move up here. I'm still standing still. Still sliding down from here. Yay. I'm still sliding down from that one. And I can't go up with that one. All right, now let's see if this still works. Whee! Yep. All right, cool. So with that done, let's see if Jolt is way, way, way better. When it comes to this, this should always have worked with Jolt. Oh, that's so much more stable. See, this is why I like Jolt. Jolt's so much better. Okay, so this Jolt does still have this problem. So we need to figure out how we can prevent that from happening. Anybody has any ideas? I'd love to hear about it. But yeah, definitely we're missing a solver constraint there. But okay, so let's first make sure that we can't just endlessly slide it. So that means we need a serious dampener in there. Yeah, Jolt's the bells. I am surprised that Jolt wasn't enabled, because the whole point of this is that I wanted to build it around Jolt. So it must have gotten reset at some point, probably in an upgrade or something. But yeah. Cool. Okay, so we've got that. Effect applied to the movement across the slider axes. Once the limit gets surpassed, the lower restitution, amount of restitution limits are surpassed, the lower, the more velocity energy gets lost. Okay, get some minimum dampening. The amount of dampening that happens once the limit defined by lower distance and upper distance is surpassed. Lots. Oh, just put it on maximum, whatever. Okay. We don't have. Right. The amount of dampening inside the slider limits. So this is outside. This is inside. Now we definitely want lots of dampening because we want it to stick where we put it. We don't want that movement. Don't care about the rest. And then movement across axes orthogonal to the slider. What? We don't want you to move at all in other directions. Yeah, that's one of the things that I find weird. One of these days, I hope they'll learn more about these things. So here's the same thing. Upper and lower angle. We don't want that. Dampening. Amount of dampening of the rotation when the limit is surpassed. Factor applied to all the rotations once the limit is surpassed. Makes all rotations slower between 0 and 1. Is it? Slider joint linear motion dampening is not supported. Yeah, that's very possible. So, was that this one? Yeah, that was this one. Well, then I guess we're not going to set that. So yeah. The thing is, I really want this completely constrained between this. So this sort of suggests to me that we could extend beyond the limits. The thing is, we don't want this to be able to rotate at all. So I'm just going to put that to max again, even though that probably sucks. Angular limit dampening is not supported when, okay. It's not even supported. If I do this, it's also not supported. Really? Restitution, not supported. Really? Softening, not supported. Okay. So we can't even set any of these anyway. Well, that sucks. Hey, buddy. Okay. Yeah, Joshua, that definitely sucks. I wonder if we can use any of the other joints that have more options. I don't want a hinge. The only other one would be a 6-dove. But then restricted to okay, let's just let's for fun use that one and see if we can actually get something better with that. So so this should now be 25, and this is minus 0.25. Okay, that's 0, 0, 0, 0. Obviously, we need to remove the other one in a minute, but you can always re-enter that one. So that should completely limit our movements. Let's see if that one works better. The other thing, of course, is that going to complain? No, that still doesn't work. But let's see if it actually works better, or if behind the scenes it's actually using the same logic, which is very possible. And if not, I'm not going to waste too much time on this because I just want the slider thing to work. Okay. Well, okay. No, it behaves exactly the same. My computer is in the way. Yay, there we go. But I don't want this to. I want this to stop moving. Okay. Well, I can create my own logic for that, I guess. You know, we can always make it so that I am having fun with this. So, we could always have some logic that this adds some forces to itself based on its velocity to make sure that it always tries to stop. But that is kind of ridiculous. Okay. I just kind of didn't want to do anything with code for this. No, this is actually before stencil shaders were added to Godot. So all that this does to create an outline is I can show how this actually works behind the scenes. So let's put that knob, and all that I'm doing is when you have a material. Oh, I don't have a material on this one. So let's imagine for a second that I've got a material on this one. I'm adding a material overlay. Let's create another material here. And what I'm doing with this material overlay is, where are we? First of all, here, we make that yellow color. There we go. Then we are doing front faces. So now we're basically making the back yellow. And then where are you? Grow. Doing grow. And I'm growing it by a little bit. There we go. Oh, and obviously I'm making this, where are we? Shaded. So there we go. We have an outline. This is not as good as stencil outlines, so definitely better to do this with stencils. But this was done before we had stencils. This is a nice way to work around that. I don't want to material right now, so I'm just going to leave that out. So yeah, a little bit of a downer that we can't control the joint as good as I'd like. I'm going to change it back to the slider joint, being that it behaves the same anyway. And then maybe at some point I'm going to test this in 4.6 and see if they've already made a bunch of improvements to that. Blake, fair warning, I do have my camera on.
Don't care.
Well, I don't think you're in view anyway, so
It shouldn't be.
okay. That's all good. So yeah, if we can't do any dampening and stuff like that, we're just gonna have to leave that alone. Yeah, the reverse grow method of outlines. So old fashioned, very straightforward. It works. That's all that I'll say about that. Okay, so we've created a nice slider that can move forward and back, but that is sliding a little bit too much. I am going to go and save this branch scene. I'm not actually going to put this inside of the add-on at this point in time. I'm just going to put that into components, and I'm going to save that. Perfect. So we can put some code around that to make it work a little bit better. Could you do dampening in code? Well, that's what we're about to do. but I'm purely going to do dampening on the movement. I'm not going to worry about the fact that we can twist it around. So I'm just going to create a script here. Obviously, we want to have a physics process script. This cable is really starting to annoy me. But I don't want to put my crest down because then, oh, I'm going to have to put my crest down. Because it's so uncomfortable on my head like that. Okay. Don't care about delta. Don't care about delta. So, what we want to do is we want to make sure that our slider joint is going to resist movement and that our slider joint is going to always make the Y and the Z zeroed out. So we kind of have our static body there. So our Y, we can always just keep pressing down. All right. Make sure our slider down equals up. Nope. Let's first do a on ready var slider rigid is slider. Yep. I always forget, is it applies central force or impulse? Which one is applies a directional force without affecting rotation? A force is time dependent and meant to be applied every physics update. Okay, perfect. So we are going to do this. Global basis dot y, which is up from the board. That might be way too much because I'm not applying delta. Maybe I should apply delta. And that would then mean that that should be a lot higher. Okay. So that's going to be pushing it into the board. Or maybe I can do position dot y. Okay. Make sure that we only do that when we are off the board. So that should prevent us from pulling it out of the board. Now, I'm going to leave the Z alone for now. Just leave that up to the thing itself. Not even sure if this really matters. But now we want to make sure that if we have a velocity, is that we work against that velocity. Oh, but that has a velocity damp. Let's see if that's going to help us prevent that from moving. Because if the damping doesn't work on the joint, does the velocity damping work on the thing itself? Still. It's definitely not. This is really weird because it's. Yeah, it really doesn't like that bit. I need to figure out a better way to do that. But it doesn't look like that's being damped at all. So is that because I don't dampen enough. Oh, you guys couldn't see that. Sorry. I don't know if that actually automatically applies, but no, that is not dampening any movement. Yeah, handle, maybe. Actually, that's a good one. Yeah, let's do that. Let's do that after I stop it. Okay. Handle. Oh god, I hate having my crest on my nose like this. Huh. Attempt to disconnect a non-existent connection. Whatever. Oh. Okay. Let's see if that higher damp works this time. Oh, that worked. I'm happy with that. Okay. Okay. That's getting somewhere. Okay, cool. Alrighty. That is what we want to see. Sweet. All right. That is good enough for me for now, for what I want to accomplish with this. Sweet. All right, cool. So. Ooh, Penguin Festival Pass 2000 wishlist on Steam. Congratulations, Z. Hey, very cool. Exciting. Sorry, I saw this notification come up. Meet you. Might keep you for now. Oop. Export. That's not good. Okay, I'm back. Hope the stream didn't have a hiccup there because I just got ooh, please configure both primary and backup. Yay. All right. Am I still here, guys? Let me know in the chat if I'm still here because I just got disconnected and reconnected. So hopefully I'm back. Very strange. Yep. Yeah, I just OBS just suddenly disconnected from YouTube and then reconnected. Not quite sure what was happening there. All right, so we got a lower value, upper value. Now make that 100, and then we get the value itself. Okay. Set well, new value. The value is new value. Okay, so lower limits, upper limits. Oh, that needs me. Alrighty. There we go. Okay. And here we do if is inside tree update value wink. Means in already we can now do that, and we can go and do a fuck for that. Cool. Oh yeah, no. Eventually, I've made a start on it, but I need to finish it. But eventually, I want to have a complete 2D viewport, 2D and 3D sort of implementation here as well. Just haven't gone around to doing it yet. That's all. Oh, my nose issues. Okay, cool. So, where are we? Bum, 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 bum. Yeah, so we got the value, we're setting that update value. So if our value changes from outside, and actually I want to do that for all of these. Upper value. Lower value. And then that becomes like that. And that becomes like that. And before we do anything else, what we need to do is if engine dot is editor hints return. We do not want to run that in the editor. We do want it run already in the editor. And that means I can now make this a full script. There we go. So those are all set. Perfect. Which now means that yeah, we can keep that in. So that should be usable now. So we want to position that on there. So we know that that's minus 25 plus 25. Yeah. Okay. All right. So this is going to be call that pause right now. Is going to be value minus lower value divided by upper value minus lower value. And of course, what we want to do first is if lower value is upper value, then sorry, but that don't work. It needs to be a protection. So now we get a value between 0 and 1 for this. Perfect. Okay, so now pulse is going to be pulse times 0.5 minus 0.25. And we can actually apply that directly to handle.position.x. Boom. Sweet. So let's go to main stage. And in theory, I should now do that needs to be fixed. All right. We want to clamp this. Between 0 and 1. Okay. Now it's not allowed to go above that. Perfect. Sweet. Cool. All righty. Okay. So that is how we do that. But now we want to go the other way around as well. Okay. So for that, we need to just first have a var was position float. And with that, I also want to do that like this. So that we remember that. Sweet. Okay. Updates. That makes sure that that is correctly set. So here we can now say if was position not equal to, actually I want to do that in process because we don't need to do that every time. Okay. So if that's not equal to position dot x, then we want to go and reverse this. So First, we reverse that one. Var pos flows is going to be plus 0.25 times 2. Okay. Or divide by 0.5, whichever way we want it. So that should now become a value between 0 and 1. Cool. Now we need to reverse this. Oh, we definitely need to go and do this first. We do not want divide by zeros. Cool. Okay. I don't need you anymore. All right. So now what we're going to do is value equals pos times that. Okay, cool. Plus lower value. All right. And now we want a signal. There we go. We made out the value. Cool. Okay. What's that going about? Yeah, that actually doesn't matter anymore. I actually made that work properly now. All right, so extend script, main stage. Cool, we got that. Not for that. Why is this whole thing orange? Oh, because it needs to be a tool script. Yay. I'm glad that it actually gives that error now. Didn't used to do that. Okay, so we should now be able to go to our slider here and to node, value changed. Oh, you know what? Before we do that, I want to go back to my slider script. Let's type that. Okay. There we go. All right. So when we look at this, what I want to do here is unready var Angular PID controller 32 PID Angular PID controller. There we go. And that is going to be, actually, I'm going to put that in the actual onReady. We can get it from any of the two hands because we're reusing the same one. A PID controller. So now what we can do is here, proportional gain, we're going to make that new value. Now our current value is 250. So obviously we want to make sure that our slider range is something better. So we already know that that is a good lower range. Let's go and make it go all the way to that. And let's just start at 250. So with that, we're there. And now we can crank that up and see how well that works. Let's also go and rename this to proportional gain slider. there. And that also means that I actually want to go and reconnect that so that that is in the name. Which now means that I can go and put that over here. Because then we can also put the another slider for the derivative in there. The last thing that I really want is to actually show that as well. Value. Wink. Text value. Yeah, that's nice and big. A bit smaller. There we go. Now flags. We want that to be a Y billboard. There we go. It's good enough for what we need. Okay. Now, in theory, when we set our value here, that should run our update value here, which means that I should be able to say, and actually I want to go with that even if we don't do that. What we want to do here is, let's actually make that an onReady var as well. onReady var value label 3D is the value, and then this becomes value. Text is value. So, okay. There we go. Perfect. We can see what it is. Woohoo! All right. Let's see if we are still up and running. Oh, let's move that first. All righty. Come on. Thing was stuck. All righty. Whoa, what's happened? I messed something up. Oh, yeah, of course, I messed it up. So I did not fix that yet. I thought I fixed that. Maybe I fixed it in a different one. You guys can't see it. My whole display internally suddenly went wrong. So the reason why that was is because my main scene, I did that, and now I'd ignored the warning because I thought I had some code in there that would actually get the right player origin. So let me have a look if I'm right at that. No, I do have the find XR origin in here. Channel, blah, blah, channels. Yep. That should work. Oh, thank you. That is right. What we need to do every time. I think it's just enough to do super, right? Yeah, I think you can even do that, but it also means that I want to get rid of that because I'm not using that. Yeah, no, I've been there plenty of times too, and but I always forget. That really is one of those things that should have a warning. Now, I agree with the change that they've changed that, but it is what it is. So I should be able to now. Oh, why not? What? Why did you stop working? You? Oh, I'm creating a feedback loop. Okay, I was afraid of that. So the problem is, we are in our process, we are calculating a new value and we are setting up the value. And then in our value, we're saying like, hey, we set the new value, go and update our value, which is then going to set the position. And it goes like ring, 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 ring. Yeah, when you set the position, it resets a bunch of things. So I have a feeling that that is our problem here now. So how are we going to do that? Well, I think the easiest way to do that is var is in process false. Okay, and all right, that should prove our theory. Let's see if I was right about that. But of course, that means that it's not actually updating my label anymore. Oops. Which means that we also need to update the label. Well, we can see that it's pretty much a lot higher because now we have our cheekiness. But does that now? It still does not like the 2 kilograms, but the 1 kilograms is pretty good. All right, I'm gonna put it all the way up, but now, sorry, that's completely good now. And that's getting there. All right. I accidentally moved it now. All right. We're getting there. No, it's the setters are called from if you set the value from outside of the setter. So within the setter, you can set the value without obviously that becoming recursive. But if you set it from outside, it actually, yeah, that actually scraps out. Like updates label. That is going to go in there. All right, so now we're going to do this slightly differently. Okay. So now if the value changes, we always change the label. And obviously here as well. Okay, so you want that does. Oh. Okay. All right. That's cool. I don't know if you guys can see that, but see how the cube is slightly slanted, and as I up the strength here, it slowly goes straighter. Not by a whole lot, but it does. Okay, so I want a second slider because now I can start playing with the 2 values. All right, first of all, proportional slider. Make that even more. At some point, I also want to make sure that we can make this thing bigger and smaller, but for now, this is good enough. All right, so now we can do another slider. Come on, don't do that. There we go. All right. Okay. Nice. Okay. Cool. There we go. I'm a little worried that I'm putting them too close together, and we won't be able to modify one without the other. But this is going to be our derivative. I spell that wrong. Slider. Derivative slider. Is that correct? Derivative gain. We've got a 10 right now, but I got no idea if that's any good. But let's go and say our lower value is 10. Let's go to 200 for that, and then 10. So we can manipulate that. We can see if that is going to help some. And then obviously right now, node value changed, boink. Boink, and that's going to be our derivative gain. There we go. All right, let's see how that works. Well, I can't really put a filter for the hands because of the whole way that we are applying forces. All right, so I want to go and put this way up. We should be seeing lots of shaking. Now the question is that going to make it go less? So let's actually, come on. Yeah. Let's actually go a bit more like this. No. I think this is way too much now then. Okay, if we go all the way back to 250, that is good. Whoa, you can immediately see that there's like a point where it stops being happy. All right. So, come on, a little bit less here. It's too much still. I want you to stop shaking. There we go. Slightly shaking still. I just want to see if that's... Oh, that's now... Yeah, that's what I'm afraid of, is when things are too heavy, it is not powerful enough, but if I put this up enough to make that go better, can't really get it high enough to really do something good with that. Because that's the thing, that with the derivative up, I shouldn't have that shaking too much. Actually, that makes it worse. So maybe the derivative is working the wrong direction, because the derivative is supposed to dampen it. Okay, that could be because we had that double negative in there. So let's go and see if we can't make that work better then. Okay, so let's go and turn that off and not make that negative. Let's see if that makes a difference or not. Okay. So, I'm going to see how I do that. It's supposed to dampen that out. So, let's see if we can. Doesn't really make a difference, does it? Yeah. It's still a little on the shaky side. All right, let's see what happens if we allow it to really. This is the thing, is when I'm not holding anything and this derivative is high, I get, well, it might actually be too much about this. It's really hard to really tell what it's doing. Gets much more shaky. Definitely gets much more shaky when I up that. I don't know. I really have a feeling that the tuning that we do is going to make it tuned properly for a certain weight. And the moment that we add weights, things go haywire. Now, one thing that I still want to try, and that we can try really quick, is Avat's suggestion, and that is turning off inertia. So let's go with that. Probably want that just to be in here. Oh, we still have all those dampers on too. Just want to have some fun with this. Just want to see how this changes. I've forgotten that I added those in. And that might actually be interfering with our pit controller. Ooh. Hmm. Okay. Oh, oops. Okay, that's making it worse. I wonder if I should be able to make my derivative negative. Okay, I'm going to undo this, but I might want to put some more effort into that. Okay, let's make that really nice and low. Good. So without inertia, we actually have much lower values all of a sudden. See you, Blakey. Okay. Let's see what it does with this then. Very stable. Very, very stable. That's very heavy, so that's understandable. Okay. I do like that. It is lots more stable. All right, we're going to up the range a bit. Let's see if we can tune that some more. All right, So that means yeah. Yep. I don't think those slashes are needed here. It used to be needed. I don't think that's needed anymore. Well, it's not giving me error, so it's happy about that. Alrighty. Fucking A. Oh. No. Character body. No, it's actually on main stage. So. We're going to put that on the 1,000. Leave that at 10 for now. So 1,000. 1,000. Let's make that 4,000. Let's see what we can do now. All right. So, bloody hell, that's nice and stable. Okay. Let's see. Okay. What happens when we put it all the way up there? It's still pretty stable. That one. I actually got, this is 10 kilos that I'm picking up on a really weird place. So I'm actually not so unhappy that I need to, and even that I can do. So the fact that it does bounce around a bit, okay, I can live with that. The 2 kilo, well, it's still a little bouncy, but it's actually kind of cool that I can wiggle it. What happens if I do that? I'm starting to think that I need to allow that to be the other way around. So, okay, let's play around with some more ranges. I think I can even up this even more. So, okay. Okay. Let's go a little bit more crazy. Still don't really know what that is. I don't care about you because we're not using saturation. Let's make that 2,000. Make that 10,000. Make that 2,000. Oops. 2,000. There we go. And then here, I actually want to make that 1,000, but I want to make it minus 1,000 so that we can play around with what works better, a negative or a positive value. Of course, if a negative value works better, then that makes that minus make sense. All right, so let's go and pick that up. Let's go and move that all the way up. So I can still do a bit of bounce, but not much. Okay, what if I put that all the way like there? It really takes out the bounce. Yeah, that's definitely overcompensating right now, but it might be because of this guy. Yeah. Should make a little graph that I can see how well that does. There's a little bit more bounce in here. Okay, what if I do that? Is that going to make it worse? Can't really see very well. Yeah, I'm not so sure about the derivative side of this. I'm I'm not sure if we are just not having any impact. How are you doing? Yeah, 10 kilos is going pretty well, but you can see it bounce around a bit. Huh. Oh, I'm bobbing up and down. I'm bobbing up and down. I think the pit controller on my character controller needs a bit more damp. Okay. So one thing that I really wonder about is because we've got a lot of damp on our hands, whether the damp on our hands is already making the derivative not really do much, or whether the derivative is just not being applied correctly. Oops. That said, I'm quite happy with how well it keeps up here. Whee! Yeah. Hmm. That's all working. Okay, guys. Kind of happy. I think that inertia made it way better. So thanks a lot for that tip. There is still a little bit of wigginess into it. Again, I can probably up that a little bit to get that a better value, but there is a part of me that sort of wonders if I need to turn the damp down and actually control the damp with the pit controller. But I'm pretty happy with this. We are getting very close to a working system. Now, the real proof of the pudding is going to be what happens once I add other more complex objects to this. Well, yeah, Sam, there is, because that's the whole thing what the pit controller does, right? Is it's one side, it is checking how much difference there is between the desired position and the real position and adjusting that. But the other is taking like the velocity into account. But I think because of the dampening that's in there, we're kind of negating the derivative. So, well, yeah, because the applied torque is how we eventually apply the values, you know, how much, which then causes the hand to move in a certain way. And that then feeds back into the data that's fed into the pit controller the next frame. So, but I have a feeling that we're now having separate systems fighting with each other, and especially because no, that's not it already. Especially because I'm doing this. Oh, and I'm taking out gravity as well. Actually thinking that needs to be taken back in. Just want to have a look at what happens if I put gravity back in, because that was one of the things that I wanted to do, is that if you pick up something heavy, that it actually sort of drags the hand down. Oh, and of course, I forget to do this. Okay, there you go. There you go. Let's see if that does anything. Okay. Now, oops. Okay, so that's good. But I wasn't expecting anything. Now the 2 kilo one. Yeah, we can see that that's slightly lower. I don't think, know if you guys can see that, but it's being dragged down a bit. Now this one, yeah, that is being dragged down quite a bit. So kind of like that. Gravity is having something to do with that. So what if we up the kilograms of the big cube? What if we up the kilograms of the big cube? And we can do that here. Scene, main, world, table, box 3. No, box 1. Box 2. Oh yeah, that's 20. Okay. That's not 20 kilograms, all right. Yeah, that's more. Okay, let's up it even more. Okay, that's actually kind of cool. Let's make it 50. Yeah, it's now 50 kilograms. Oh, yeah, that's definitely a lot harder to pick, but I do get that bounciness again. Obviously, that's not how that works. And that is where, oops. Still bouncy. Bouncy more. Yeah, it's hard to see whether this is helping or not. Yeah. Yeah, I'm really feeling that that the derivative thing isn't working properly yet. And again, I think that has a lot to do with this. So I actually want to go. Let's see, what is that by default? If I just do, you can see that over here. Almost combine 0. Okay. Actually, I think I should have copied that first. 0, 0. And I have a feeling that because of this, my bit controller is going to be completely overpowered. Probably need to. Oh, I've been playing with a version that doesn't use applied torque unless the hand is colliding with something to make the hands feel more responsive when they're not interacting with physical controllers. Yeah, that could potentially be a good one. And hey, Von Hacke, how you going? Yeah, been a while. Hope you're well. Okay, so this is probably going to be completely bad. Yep. So let's go and set our values back down. Here we go. So I actually want this to be 0, 2000, and that's going to be at 100. And then the derivative, I'm going to do minus. Actually, I'm going to keep that on that, but I'm going to make that 0. Well, you know, family comes first, so that is probably a good thing to be busy with. I'm going to put that on 0, and now I'm going to put that on, let's say it was 100. Yep, 100. Okay, cool. Let's see if that makes more sense. No, it's definitely not happy without a damp. Of course, now because it's swinging around. Okay. Okay. So now the derivative is actually doing something. Hmm. Okay. So it's definitely, it was supposed to be negative. That's good to know. Okay, so I'm definitely going to change how that works. But I need to really crank that up to actually make it do something. Okay. So. So first of all, that actually made sense. And I'm actually starting to think that this doesn't make sense. Because it's not cumulative. So let's take that out. I'm going to start with these values again that don't make sense. So we're going to start with a really bad swinging hand. Because we need to go and put this up. Oh, blink. Okay. Come on. Oh, wait, that's right, because I made that negative now. Come on, come on. There we go. You need to be a bit higher. Yeah. Okay, I'm gonna guess that I need to put you a bit down because you are being way overpowered. Okay, here we go. All right. All right. That's good. Ooh. That's decent. Oh, and this is of course movements because I haven't done the movement yet. Of course, because now that I take to have taken the dampening out, my movement control is of course not good enough yet. That is. Okay. Okay. So, all right. We're zooming in on something. Oh, you guys couldn't see that. I'm so sorry. I forgot to move the thing to the screen again. All right. So that now needs to be like that. I got that to 80. I want to go and do that. Like so. And now we need to copy that over here. Okay, I've already changed that. Very good. And then the derivative gain needed to be 80. Yeah, because the thing, of course, is when we look at the collision hand code, okay. So yeah, I am actually, I am applying damp here, but I'm taking a damp from here, which I just completely took out. So now I'm using the default linear damp. So yeah, so I eventually I want to replace the linear movement with the pit controller as well. Okay, I think this will do. So hand is stable. Very cool. That's good. So now if I up this a little bit, let's see how much I can up it without my hands going weird. Okay, cool. Oh. Okay, I'm happy about that. That feels good. That feels relatively good. Okay, can I, well, I've got that. Can I up this a little bit? That's too far. Move it down. Oh, that's too much. 100, 120. A little bit too much. Okay. Ooh, stable. Oops, sorry. Okay, so that is still a linear movement. That's fine. We'll get the linear movement later. Yeah, that's understandable. And that is pretty stable as well. Oh, oh. Ah, it's going into me. Go away. I did that again, did I not? Oh, I'm so sorry, guys. I keep forgetting to move this over here. Hey, Neubart, how you going? Thanks for joining again. Okay, so let's move this up. Let's move this up a little bit more. There we go. I think we can move this up a little bit. No, that's too much. Hey, don't do that. Don't do that. Come on. Back. Back a little bit more. It's really like this. There's like a sweet spot where it starts to go wrong. So I'm going to up that all the way to 4. It still feels good. That still feels good. That still feels relatively good. All right, so I think now we're at a point. Now we're really at a point where I think our movement needs to have a better setup, but okay. I'm pretty happy about this. And the other thing that's going to be interesting, oh shit. The other thing that's going to be interesting to see. Okay, so exactly at 150, it started to go wrong. Come on. There we go. What was I saying? So yeah, so one thing that's going to be interesting to see whether I've messed anything up when it comes to frame rate sensitivity. So I probably should check if this all works the same with a better frame rate. But yeah, no, I'm actually pretty happy with how this is working. Okay, turns out my PC can run for it like 1 frame per week. Yeah, that's not good. Is there a workaround that isn't sending the files to my Godot app natively on the VR? You mean when you're running Godot on PC and then uploading to your Quest so that you can run it natively on Quest? Or are you talking about if you run Godot itself on the Quest and you want to have the project running on your Quest? Because in the first, obviously, yeah, you need to always upload the app to the headset every time, and there's not really a workaround for that. And if you run everything on the Quest, yeah, then everything needs to be on the Quest. However, what a lot of people do, and I don't have a good guide for this. But David Snowpack on the Discord, he's got plenty of experience. But what they do is they install a Git client on the headset, and then you have your files locally on your PC, and then you have your files, a copy of the files on your headset, and then you just use Git to sync them. So that's a nice way to transfer things back and forth. But yeah, that is a difficulty. If you want to run everything natively on the Quest, then you have to deal with the project files actually being on the Quest. There's not much that you can do about that. Okay, so let's move that to 4,000. Let's move that to 125. Let's make sure that that is represented here as well. Actually, no, I'm going to do that like this. 3,000, 10,000, 4,000. I think I am going to leave it there for now. Let's test it one more time. Oh, that's early. Okay, that is stable. So I want to see if I can move this way up and keep it stable. I think the higher this is while it's still stable, the better. Okay, that's good. That's good. That feels pretty good. Okay, it feels. Again, the movement is a bit of an issue, but I think that is because we need a pit controller for movement. And that is still, even though I've upped the proportional gain so much. Yeah, 125 was probably a really good choice. So let's move this even further up. Okay, we've sort of found the upper limit of that. A little bit less. Almost. I think 6,000 was pretty good. Yep. Yeah. Yep. Yep. I think I'm going to leave it there. Let's put those values in. Yeah, Joshua, I think that is pretty much coincidence. So I'm going to put that to 6,000. That was still good. I'm going to put that to 6,000. Okay, now the other thing that I want to do. I don't actually know what refresh rate we're running on 90. Oh, so only support 90. Because I'm running on SteamVR. I'm going to up my physics rate to 2. So all the physics are going to run at double speed. And I just want to see if that messes things up or not. Just to see whether we are somewhat stable physics-wise. So that's still good. That's actually a lot better. I think actually running physics at the double frame rate. I might make that the default. running physics at double frame rate. It is so much more stable. Whee! Boink. But the most important thing is that it looks like the values are still working the way that that is expected. So I'm pretty happy about that. Ah, yeah. Cool. All right. Cool. So that's actually kind of interesting. Just upping the physics to double the rate. So we're running at 180 frames physics. I wonder if that's because now we have 2 frames in a row with the same inputs, and if that somehow stabilizes things. But you don't hear me complaining about that. Yeah, I'm happy. This is working much better than before. I do need to bring a bunch of things over from my other demo and see if they all work properly now. Or if there are weird issues. We obviously want to apply a PID controller for the linear velocity. So that works properly, because now the linear velocity isn't working properly. Yeah, no, I'm really happy, because I was really struggling when I was originally working with this. Now, I do think that when I look at a couple of things that I know now, like I think the biggest thing that I got wrong in my original, so it's actually possible that this version could be made to work properly. Now that I know that, I think this was the main thing where I went wrong. That helped a lot. That is only applicable to the PID controller approach, but yeah, happy about that as well. And then obviously, yeah, that one is unfortunate. I think that could further stabilize it if that would work, but I get why that is a problem. So there is a part of me that sort of wants to try if this still works or can work. But yeah, the problem is that that shouldn't be get earlier. That should be the same axis angle approach. But I kind of like, I like the controllability of having the PID controller. That does really make a difference for me, I think. You know, in theory, that should be more accurate. Although, again, within, you know, does it do what it does? This should be more able to control I don't know what I was going to say. Yeah, this should be able to more predictively control things, and work better if when you pick things up that it adjusts the fact that you're now holding something more heavy. Yeah, I'm happy. I think this is a huge step forward. I'm eventually going to remove this debug stuff, because now that we know that it works, it's no longer there. We no longer need these things because we've now applied that. So yeah, we probably need to replace this with another PID controller. I'm probably going to simplify the Angular PID controller as well. But that's just cleanup that I will work on later. So yeah, I'm super happy with the progress that we're making here. But I am going to leave it there. It is almost dinner time for me. So yeah, thanks everybody for watching. I hope it was informative. And yeah, I think I'm going to take the old logic out as well. I have that always in my in Git and this VCS. You can always have a look at that. So we pretty much have this as the new logic. I will be cleaning up the Angular PID controller. Is that something that we want to really quickly do right now? Seeing that we don't do integral again, so really should be renaming that to an Angular PD controller. Which actually means I'm happy to take that out. I actually don't care at all about any of this. We don't care about derivative initialized. We don't care about these. We don't care about that. We don't care about you. We don't care about you. We just care about you two. Don't care about you. And you know, that's kind of no longer this. So I think in this case, you can take that out because that is no, whoops. That is no longer applicable. That needs to be called Angular. It's not PD controller. Let's go and close a bunch of things down because I never like renaming stuff when it's open. So I'm going to go and close that. And now in file system, no, this is a MISC. So I want to go and rename this guy Angular PD controller. There we go, and that becomes Angular PD controller. Make it clear that it is not a PID controller. There we go, and let's go and search, find in files for PID controller, find. Okay, so that needs to change. I think that is actually true. Okay, that more looks like we have got an issue with that. So let's actually go first here. Yep, that's good. Okay, that is good. Let's go and leave that for now. However, let's see. We probably need to go and fix that behind the scenes. So PD, where are you? Hands. Yep, so I'm not going to rename that here, but I am going to change this over here. So that is correct. Okay, got to close. Now I should be able to do that without it. Oh, that's still cached. It's still cached, okay. Okay, let's first go over here. Let's first rename this to PD controller. PD controller. Oh, that's not defaults. That is defaults Angular PD controller. And that is not in player, but that is in hands. Oh, and that is why it's giving errors, because I was loading the wrong one. What about now, dude? Are you happy now? Default hands Angular PD controller. Yes. And now it's actually happy. Okay, sweet. Now the big question is, does it still work? Have we got any here and here? No, of course not. Oh, that's all. Wait, was that just a leftover message, or was it actually? That was a leftover message from when we were renaming. Good. So now, do we just have those left? Cool. That's set correctly. Cool. Sweet. All right, let's try it one more time just to make sure that we didn't screw something up. But I think, yeah. 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 Super happy. Woo. Boink. I like it. I like it. Alrighty. 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 Super, super cool. All right. So I think am I gonna go and clean this up already? Yeah, I don't need this anymore, so I actually really want to take that out. That cleans that up. Okay. All right, I think with that, we've got all the Angular stuff done. All right, so that means in here, got that, I've got that. It's commits. Okay. I don't think I've pushed this in before, so I should be able to do that. Perfect. I'm going to go over here. Let's actually do. Oh, I'm pretty sure. Check out minus B demo. That. Demo changes for Angular. Oh, fit controls. And now I realize that I want to do one more thing. I want to go and do one more thing. On the collision hands. And this is really nitpicking. I'm still going to do it. I'll rename that. Okay, and I want to rename it here too. Yeah. Oh, and that means that this needs to also be changed. Oh, there we go. All right. All right, try one more time just to make sure that that didn't screw it up, because that was actually a fairly potentially destroying change. So, final test before we end the stream today. Ah, see? That's why I test. Why? Gain value float null. So character less collision hands, angular PD controller. Ah, because of course it has lost that now. That's one too. There we go. That's the danger of renaming stuff. And that is good. And it was good, they say. And it's working perfectly. Yeah, super happy. Okay. All right. All right, that fell on the ground. Very good. I'll pick that up later. Okay. Now I think I am really where I want to leave off. So let me just first make sure it's all in Git. And obviously that's gonna make that change as well. Oh yeah, of course. There we go. Where are you? And that's all. All right, everybody. That's where we're going to leave it today. Again, like I said before, hope everybody enjoyed it. Hope you learned something. And yeah, see you next time. I might stream if I have time in the weekend. Not 100% sure. But else, might do another stream on Monday to continue on this. So, hopefully see you then. And till next time. Bye.